Any questions?
For the quiz on Thursday, I think you said,
Mm-hmm.
is it just on the concepts of the chapter for, because we have two homeworks, or is it on both the homeworks or just the concepts?
The quizzes, the in-class quizzes are based upon the homework problems that are assigned. So I'm gonna take two of the ones that are posted, you have solutions there so you can work them out ahead of time. I'm gonna change the numbers, but I had a student a number of years ago who worked through the textbook problems so much that when it came time to the quiz, the person solved it with the same numbers from the textbook. You know, given that and other examples, that student was great at memorizing. No idea how to solve the problem.
Did you get back a test yet or no?
No, they're either that stack or this stack. I plan to hand them back at the end. They were new tears of joy, but it was not weeping in sadness either. Other questions?
Class average-ish.
5,273.
Love that.
I don't remember.
I guess.
Oh, gotta do the focus. All right, so let's pick up where we left off. Let's actually do a problem using our newfound knowledge of centripetal motion. So this is a side view. This is just a snapshot in time because B is swinging around in a circle. So side view. Overhead view. There's a hole in the middle. There is B. It is swinging around in a circle attached to a string. Ideal string, and the string is close enough to parallel to the table that we don't have to worry about that angle. And I know it's going to shock you, but the first step, force diagram. I really only care about B and A as far as the forces go. But you can throw the rest of it in there if you want to, as long as it doesn't take up so much space that you have a hard time telling the important parts. So, what are the forces?
There's tension on the top of A.
There's gravity, bottom side. Weight from bottom side.
Of talking A.
A and B. But it's a different weight.
Gotcha.
Would you have tension on the left side of B?
I hope so. We got one more.
Normal force going up from B?
On B.
On B.
I'll put a Y sub B there. There's a normal force acting on the string also, because where it's touching the table, but we're not worried about that. All right, so what's next?
Just right there.
Oh, yes,
The box A is not moving,
correct.
and box B is spinning.
Yes. Now, in reality, if the string were not ideal, as B spins, the string would twist, so A probably is going to pivot some, but we're not worried about that. Okay, so after the force diagram, what's next?
Acceleration.
Okay, what is the direction of acceleration of A?
Shouldn't have one,
Why?
because we, it's at equal with 3.
Yes. All right. So we'll add this to it in a different color just to make it clear it's part of something else. So A equals 0 here. A sub A. What about for B? What's the direction of acceleration of B?
Not that way.
Towards B?
Yep.
All right. Since F equals ma, I hope we're at least accepting that. And if not, then quite the rest of the semester is going to be tough. Acceleration has to be in the same direction as the total force. So if acceleration is that way on B, where's that, what force are we missing?
Oh, that force.
And what force is that called?
Friction.
From what?
Friction less. No, friction.
From the tension.
Tension's going that way. Ibrahim is saying the acceleration's that way.
I retract my statement.
Which way is the acceleration acting on B? Yes. For things traveling in a circle, the acceleration is because of the change in direction, it's towards the middle. That's the whole centripetal thing. The acceleration is that way. Because B wants to go into a straight line, but something keeps pulling it back in. That's the centripetal force. All right, so we've done force diagram, directions of acceleration. What's next?
Decomposing vector.
Before that?
Oh, coordinate axis.
Yep. All right, so I recommend picking the direction of acceleration for being one of the positive directions. And then out of habit. And then for A, acceleration is 0, so pick up or down to be positive, it does not matter. Anyone with an opinion?
Down positive.
All right. Now what?
Decomposing vector.
I think you said decompose the vector.
Yeah.
What do we need to break up? Skyward?
Nothing.
Okay. Now what?
Substitution. Oh, wait, never mind.
Equations of motion.
Yeah. E. Then comes substitution. So the equations of motion. How many equations of motion are we gonna have?
3.
All right. So we'll have an IV hat, JV hat, and what we'll label as the plus. So, somebody, venture forth with one of them.
Okay. We have FC for IV hat.
Okay.
FC minus, or no, just FT equals M A B, or subscript B. Yeah. Like that.
All right. One down. Two to go.
YB minus WB equals M subscript B A subscript or 0. There you
I hope it's 0. If it has the same acceleration as the first one, that thing is going to be, I guess, shooting off like that.
And the last one,
That's good. New voice.
F of T minus W subscript.
All right, as far as the math goes, it doesn't matter. As far as the process goes, you said down was positive.
Oh, yeah, so it'd be W, A minus FT. Okay. Equals MA. And then up zero.
Yeah, 0. Questions about these?
So two of the equations are equal to 0.
Yes.
Will that equal to zero always, like, always be the two equations that are going in a, like, parallel direction? They're not-
No.
Okay.
No. It just happens in this particular problem. If you set up your coordinate axes right, then since these are both for mass V, one of them hopefully is 0, the other one's not. It's not a requirement, but just recognize, let's say we're accelerating in 2 different directions. These are not necessarily, you would label this as AB, I, or X, or whatever, and this is a different A, have a different subscript. All right, what's next after the equations?
Substitute.
Okay. So for what do we have an independent equation?
Wait, equals. What was it?
MG.
MG?
Yeah, that's a, even though it would probably be written at the top of the quiz or test, it's something you probably should know cold. All right, so we got W equals mg, and we have another independent equation.
The tension?
Tension is always problem specific.
Oh, okay.
It relates
Oh.
to what we're talking about now.
So we have r hat v squared over r.
Be negative r hat, you don't have a negative there, you need to adjust
Yeah,
that.
it is negative.
Now, the negative r hat is a direction that means it's towards the center, but we've established that to be the positive direction, so I don't have to, I'm not putting the vector here. The vector's implied. All right, so we now have our tension in this problem is equal to mass of V times V squared over R. We have Y sub V is equal to MVG. And tension from this equation is equal to MAG. Now what? We're trying to solve for V.
Would you start putting numbers in? Or would you?
I would do one step first, but you could. Did you want to do numbers?
No, I was just asking.
All right, first off, this middle equation not really doing anything for us in this problem, so ignore for this problem.
Is that because it's going vertical and we're kind of focusing on the tension?
That, and normally, no pun remotely intended there, when you're dealing with a normal force for motion that is perpendicular to the normal force kicks in when you have friction involved. There are exceptions, but so far, since it's frictionless, we're not worried about the normal force.
Okay, so set MAG equal to MVV squared over R.
Yeah, we have two unknowns here. We don't know V, we don't know tension, so we have to get rid of one of them, and Abraham went for the substitution. So we have MVG try that one again, that should be MAG. Is equal to MV V squared over R. So what is the formula for V in this problem?
So what's the formula for V?
Yeah, I mean, given this algebra exercise,
Well,
it's not a matter of looking at past notes, it's a matter of looking
So
at.
is it just like square root?
The square root of R times M subscript A divided by MB.
Alright, so R,
R
M
times
sub A, G,
divided by MB.
yep, there we go. So now let's plug in some numbers. So R I said was 0.4 question.
how do we get the R?
Fraction.
Alright, you're solving for V, so you have to isolate first V squared. So we have to get rid of this, so if I'm dividing by R, I multiply it in order to get rid of it. So if I'm multiplying times MB, I have to divide by it to get rid of it. In essence, I'm multiplying both sides by R over MB. On the right-hand side, they would cancel. The left-hand side, I'm left with R over MB times MAG. And then that's V squared. To get rid of the squared, I undo it by square rooting. And NA is 3 kilograms. MB is 1 kilogram. Oh, sorry, that should be NA is, oh, oops. Times G, 9.8 meters per second squared, over 1 kilogram. What is the real answer?
I was about to say, it's a crazy skin.
One of these days I'm gonna nail it.
3.429. And that's the V,
That's V.
and we just plug it into the MV, V squared over R times.
Sorry, what was the question?
Do we just plug in that number to the original equation, like the MV, V squared?
We were trying to find V, so we would stop here. If you wanna check yourself, then, yeah, you plug into here, or plug into the initial equations if you're checking yourself. If you're feeling confident, cocky, you got an answer, it makes some sense, physical sense, move on. Because nothing ever goes wrong with just rushing through. All right, our first centripetal motion problem, I'm no doubt exciting. You're just all abuzz, just can't wait till you can go home and tell family and friends. But it's gonna get even more exciting. Are we ready for it? Carolyn?
This might be a dumb question, but is this speed or velocity?
If I say how fast, it's looking for a speed.
Oh, okay.
There's not a direction involved here. I think that's probably the AC guy telling me he's on his way. So it is speed. This in V squared over R, whenever you aren't gonna see a vector squared, it should be a scalar, so it's speed. questions?
In this situation, what does box A do? Do we need box A to solve this?
Yes, because box A actually is what's providing the tension.
Oh, okay.
Well, it's part of it. If you snip box A, while B is circling around, B is just gonna go shooting off,
Okay.
because you're dropping the tension down to 0. And A would fall. So you need B to keep A up and A to keep B traveling in a circle. But if they made our lives better. Questions? All right. All right, so B is swinging around in a circle, and I don't have the prop that I want, so I'm gonna go grab the prop. I'm just gonna let the recording just keep going. Be right back.